We're asked to use the comparison test to determine whether the series converges. Remember, the comparison test is where you look at another series that you know of, like a p-series. You know that a p-series converges if the exponent on n in the denominator, if that's greater than 1, you know it diverges if that exponent is less than or equal to 1. So we're looking for some sort of series for b sub n to compare it to. Okay, there technically should be an infinite amount of different answers for b sub n because there's lots of different series we can compare it to. But the one they're looking at you to compare it to is the one that makes the most sense. It's 1 over 5n. Okay, because we know a sub n is always going to be just a little bit greater than b sub n because of this minus 1 portion. Okay, a sub n is always going to be a little bit bigger because the denominator is always going to be 1 smaller than the numerator. We're dividing by something smaller. So a sub n is bigger than b sub n. And so since we know something about b sub n, okay, this is just the harmonic series, multiplied by 1/5. B sub n is divergent, and then since a sub n is greater than or equal to b sub n for all n, the series is divergent. Okay, so that just comes from the comparison test, the definition we have in the text. If you have a divergent series for your b sub n, and if a sub n is always greater than b sub n, then you know that one has to diverge too. A divergent series is one that just keeps growing, never stops growing. So if b sub n diverges, that means it never stops growing. And if a sub n is greater than b sub n, that means a sub n never stops growing.